Welcome back to CAD/CAM tutorial. Today we are going to design and assemble a differential gearbox in Solidworks. Differential gearbox will adjust the wheel rotation while turning a vehicle. So this is the gearbox. Each and every parts we will design and assemble in Solidworks. See, this is the drive shaft, and this orange color shaft, it is going to wheel, and while taking turn it will adjust according to requirement. So we will see, and I hope you will enjoy this tutorial. So let's start. Now we will sketch our first gear G20. So select assembly, okay, and we will drag a gear from our library. So just go to design library. In library there are many options. You have to just go ISO. In ISO there are one folder power transmission. In power transmission, gears, and here bevel straight gear. So just drag this gear. Now this all shortcuts will come in left hand. Just wait. See, it's come. Now here we will select our first gear. So module keep 5 mm, number of teeth I want 20. Then pinion number of teeth also keep 20. Pressure angle always 20. Face width make 25. Okay, then hub diameter 75 and this 70 mounting distance. That's it. 0.8 nominal shaft. Select OK. Now it is asking we want more numbers. No, so select cancel. Now this selected. Now first, before saving, just select make in proper coordinates. Choose front plane. First select this body, right click, select float. Choose front plane, press Ctrl key and select plane 1 and select matte. OK. Now again choose top plane, Ctrl key, plane 2, select matte. Select here OK. Now the last right plane, plane 3, select matte. Coincident, OK. So now this is in proper position. Now we will save this drawing. Save. In desktop, create one folder, differential. Open and save first part G20.1, and this one save as a parts. And here make sure all components should be selected. Save. Now cancel this. Now drop down and open your folder differential and drag into the Solidworks. Process feature no. Keep plain white. Now we will do some modification here. Select this face, sketch, select circle, and we want to draw a circle and keep the diameter 25 mm. OK, and let extrude it up to 80 mm reverse direction. See, OK. Now this one we will save as G1. Save as. Now we will do some little modification. We will do it later. Now select this body, select this diameter and save as 40. See, it's become 40. Again select this, and this height, length keep let's say 200. Select, refresh. Now it's 200. Now save as G20.2. This is second gear. Now select the whole body and go to, and let's assign some color. The same assign to this body also. Okay. Now save as. Now let's go for a next gear. Now we will sketch next gear. So save the next gear, select, open, new assembly, cancel the begin assembly and go to library, and here select straight bevel gear. We want to just modify this gear. Module 5, number of teeth, we want 60 numbers. It will calculate, it takes little few seconds to calculate. Okay. Now pinion number of teeth, I want 40. Okay. Pressure angle 20, that's okay. Face width keep 40. Now diameter of 75 and mounting distance keep 200. Select OK. Cancel it. Now change. Now we will make in center position. So right click on the body, select float, choose front plane, press Ctrl key and plane 1. Make relation coincident. Okay. Now choose top plane and plane 2. Select matte, coincident. Okay. Now the last one, right plane and the plane 3. Select coincident. Okay. Okay. Now this gear we will save as a save G60 and save as a parts, and here make sure all component. Okay. Now this assembly delete. Now open the differential and we will open our G60 part. Select no feature. Now here we will do some modification. Now select this face, sketch, normal, and draw a circle here. Make sure from midpoint. Assign the diameter 40 mm. Okay, and select extruded cut and select through all. Select OK. Is selected. Now select this face, sketch, select this circle inside, click convert entities, select circle and draw one big circle and keep the diameter 160 mm. Okay, now select extruded boss and extrude up to 40 mm. See, select OK. This 40 mm extruded. Now select this face, sketch, normal, select corner, center line, draw vertical and horizontal two center lines, select corner rectangle, assign dimension 95 mm by 20 mm. Okay, now select this rectangle, choose mirror and mirror about this line, select OK. Now select this center line and these two lines and make relation symmetric. OK. Now select smart dimension and assign the gap between these two, select 140 mm. Select OK and select make 80 mm only. 80 mm is enough for our job. Okay, now select extruded boss and extrude up to 95 mm. Okay, now select this face, sketch, normal and create one circle here. Create the diameter 25 mm and the distance from outer line 25 mm. Select OK. Now select this line, right click and choose here, select midpoint. I think not selected, again choose midpoint. Now midpoint is selected here, press shift key and select this point and make relation horizontal, select OK. Now select extruded cut and choose through all. See here, through all, OK. Now choose chamfer, select 20 mm and select this four corners, up, down, select OK. Now here we want to cut something, so select front plane, sketch, normal, select a line, draw a line, make sure it is vertical, assign smart dimension and keep the gap 40 mm. OK, and select extruded cut. Select this arrow outside. OK. Now see outward cut. So this is our gear 62 is ready. Now save as G60 and assign this gear as a glossy blue. Select the body. Again choose select the full body. Now see, now save this gear. Now this is our G60. Now we will sketch drive shaft gear. So select new assembly, OK. Just cancel it and go to our library. Choose toolbox. If it is not come, select add-ins now. Now it comes, and here we will select ISO. In ISO, go to power transmission, gears, and at the end there is a one option straight bevel gear. Just drag it. Now let option will come here. Okay, module keep 5 and number of teeth we will reduce up to 40 and pinion number of teeth we will increase, make up to 60, and the pressure angle 20, face width 40, hub diameter 75, 200, and that's all same. Okay. It will take few seconds to calculate, so just select cancel. Now we will do one thing, we will just assign the coordinates. So we will just make the in perfect plane, choose front plane, control key plane 1 and make relation but first select the body and select isolate, body should float. Now select front plane, plane 1 and make relation matte, it is coincide. Okay. Now again go to select top plane and plane 2. Okay. Now the last one right plane and plane 3. Okay. Now it is in perfect plane. Now let's save it. Save as, we will save as a parts and give the name G40. This is drive shaft gear, and here make sure all components selected, save. Now cancel this, don't save. Now select cancel, open part and select G40, open. Here select feature recognition, no. Now we will select front plane, sketch, normal and draw one vertical line. Drag this vertical line down, both directions should be down. Now select this line, shift control and select this line and make relation collinear. Okay. Now select here extruded cut, select flip side to cut, keep through all. Okay. Now this portion we cut it, we don't want this. Now we will create a new face, we will create a new shaft here, sketch this face and draw one circle and keep the diameter 60 mm and let extrude it 150 mm, but make sure reverse direction. Okay. Now the whole body we will assign some color. Green color. Okay. Now this is green color. Now save this body. And let's start the assembly for differential. Now here we will start the assembly of differential. So let's start. Choose new assembly. Open. First bring G60. Okay. Now let first select our set our face. Make high quality. Now browse the next part, G21. We want to do some modification in G21. First assign met. Select this corner and this inside radius, reverse direction. Okay. Now press Control, click this part, drag and create one more. Now select this circle, met, and select this circle. Select reverse. Okay. Now we want to do some modification in this part. So select this part, open part. No. Select front plane, sketch, normal. We want to cut because this is bigger. Select a line and make the dimension between 20 mm. Okay, and select extruded cut. See, is going to cut through all and make this arrow reverse direction. Okay. Now this is cut. Let's assign, go to paint and assign some color, candy apple. Now this save this part, cancel, save as in assembly. Now see, now browse our, insert our another G20.2, select here, press Ctrl, drag and make one more. Now we will make relation. Select this circle, mat, select this inside. Okay. Now select this face, round shaft and this shaft. Make concentric. Okay. Now select this face and this face. And here select gap 140 mm and select reverse, choose OK. See, this is fixed, select OK. OK. Now we will make some relation. See, first we will do one thing, just met each other. So we will try to do with the help of front plane. Try this G20, select front plane, press Ctrl and front plane of body, choose met. Select parallel, OK. Now select the next part, G20.2, front plane and body front plane. Select met. See, it is adjusted, parallel, OK. Now just select the third part, front plane, met. But here see, it is not matching, so we will make some degree. Select degree and make 45 degree. See, now it is perfectly matched. OK. Now the last gear, front plane, met. See, it is coincide here, so choose degree, 45 degree. Now see, it is perfectly matched. OK. Now it is fixed, it will not rotate. So we will assign first gear rotation. Select mat, choose mechanical, select gear. In gear, first select this face and this face. It is showing mat not over defined, but select OK. Later we will select 75, OK. Now select this face and this face. Choose gear, 75 ratio, select OK. Now the third one, select this face and this face. Gear, 75 by 75 mm, OK. The last one, this one and this one. Gear, 75 by 75 by 75, OK. Now see, it is showing something error, so just go to our previous tutorial, mats, and unsuppress the 4 mats. Press shift, select these 4 mats and select here suppress. Now see, there is everything defined. Now let's rotate. See, a beautiful gear rotation. Now first save this assembly. Differential assembly. This is fixed, it is not rotating. We will see later how to rotate this, but see, it is very beautifully rotating our differential. Now we will bring next part. Now we will create a new part in this geometry. We want to create a case for this differential body, or you can say a body. So select here new part, click this part, select edit part, go to parts and select front plane, sketch, normal, no, front plane exit. We will choose the front plane for this gear, front plane, sketch, normal. Select corner rectangle and draw one rectangle. Select offset entity, select 40 mm and keep reverse direction. OK. Choose center line. Draw one horizontal center line. Now make some relation. Select this line, make sure, be carefully, and select this line, collinear. And here also this outer line and inside line collinear. Now this relation created, choose the smart dimension and assign the dimension from inside line 170 mm and keep the overall length 450 mm. Select OK. Now select extruded boss, choose mid plane. Select 300 mm. OK. Now select this face, sketch, normal. Select circle and draw one circle. Keep the radius, diameter 75 mm. OK. Go to feature and here select extruded cut and extruded cut up to thickness 40 mm. OK. Now select this face, sketch, normal, and here also create one circle and keep the diameter 40 mm. And select extruded cut and keep 40 mm inside. OK. Now we will select top face, sketch, normal, draw one center line, select circle and draw one circle in midpoint and keep the diameter 60 mm. OK. And select cut up to 40 mm inside. OK. Now just exit from the sketch. Now see, this is the casing for differential. Now select this body. OK, this body fixed. So select this gear and click float. Just float this body and we will make some relation. Choose mat. Select this inside circle, clear. It's not going to select proper. Select better first disalign. OK. Now select this circle, mat, and this circle, coincident. OK. OK. Now let's see it is rotating or not. That's it. Now it is rotating. This is what we want. Right click on this body and select transparent. Now see it is rotating. This is our aim. Now hide the component. Now you can see it is rotating like differential. Now some more things are balanced. Save it, save all, build and save the document. Now here you can see this rotating. This is our differential and it is rotating. Now this is the one wheel and this is another wheel. The drive shaft we still need to make. So first we will create some gear ratio between these two shafts, because while turning the vehicle both the wheel have different rotation. So select mat, choose mechanical mat, gear. First select this shaft, then this shaft, and choose gear ratio 10/20. Select OK. Now see, the rotation is quite different. That means the ratio of rotation is quite different. Now show the component body. Now click on the body and change transparency. So this is the case for differential. Now see the differential rotating inside both the gears. Now we will create some, we will add some another gear. Now we want to do some modification in this body, so change transparency, select this body, first select extruded boss base, select this as sketch, edit, normal, and select this line and release this, delete this collinear command. OK. Now just drag out, choose smart dimension, select 350 mm. This dimension 405 mm. Select OK. Now this hole also we want to shift it, so select this last hole, edit, normal, select this command and delete this relation concentric. Now drag this hole here, make sure both the hole and this center line should be vertical or horizontal. Assign the distance between these lines, select 180 mm. Exit. Now exit from the, now select this box body, change transparency. Now we will browse our next part, next drive shaft gear, choose insert, browse and select G40. OK. Now select this inside hole, mat, and select this gear, select OK. Now you can see it is not fully matching, so we will do one thing, we will little shift this hole Change transparency of this box. Select the hole, edit, make this one little more, 185, exit. Now our gear almost met. Now just hide the change transparency of the body or case. Now the drive shaft, this is the drive shaft gear. The drives from engine comes from this shaft. Now we will assign the gear ratio between this drive shaft and this G60 gear. So first choose the position, proper position. Just shift the gearbox according to the place, or you can select it by making some relation, but we want to save some time, so we will just adjust accordingly by hand, manually. Now let's assign some mechanical relation. Hide this body first. Okay. Choose mat. Go to mechanical mat, select gear. And in gear select this shaft and select this shaft. And make the ratio 2/3. Select OK. OK. Now let rotate. See, it is rotating. So our differential is ready. This is the drive shaft. A drives or a torque comes from engine, and this shaft will rotate both the wheels. These are the wheels. When our vehicle going to take a turn, this wheel adjusted by according to the requirement. See, this is freely rotating. First save this geometry. Okay. So this is the differential. Differential, main aim of differential is to just adjust the, just show the body. Select body, change transparency. Right click on the body, and body is always keep fixed. So I hope you enjoyed this tutorial. Don't forget to share and like our video, and subscribe our channel for more video and more projects in SolidWorks. I hope you understand the principle of differential gearbox. It just transmits the torque from engine to wheel, and the wheel will adjust according to their requirement while taking the turn a vehicle. I hope you enjoyed. Thanks for watching.